Today we're going to be talking about how to do operations with whole numbers and integers. And of course we're going to say that we should probably differentiate what's a whole number and what's an integer. Whenever you're talking about the number line, whole numbers are going to be anything 0 and on up. So probably the first numbers you ever learned about in your mathematical career. 0, 1, 2, 3, 4, 5, blah, 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 blah. Integers tosses on the second half of the number line. So we're also including all of the negative versions of the whole numbers, also known as their opposites. So -1, -2, -3, -4, -5, etc. Importantly, this isn't dealing with fractions, not dealing with any decimals, nothing like that. So those are future videos. Here we want to just make sure that we got all the operations straight whenever we're dealing with integers and whole numbers. If you don't have a really solid grasp on integers in particular, where we got negatives in there, the rest of mathematics is just going to be a very, very bad time. So it's very good to have just a solid grasp on that. But without further ado, let's go ahead and kind of dive a little bit deeper. Whenever you're thinking conceptually about integers and whole numbers, you really want to think about 0 as the pivot point that differentiates the positives from the negatives. 0 itself is the only number that does not have a sign on it. In order to understand whole numbers, it's probably worth thinking about place value a little bit. So if, for example, I had the number, let's say, 5,763 and 51. The way that I would read that in terms of place value is the ones place as a 1, the tens place is a 5, representing 50. There are no plain hundreds. The thousands place is a 3, the 10,000s place is a 6, 100,000 place is a 7, and the millions place is a 5. In conventional standard English, we differentiate basically every third place value by a comma. This is different in some other cultures, so particularly if you're coming from, let's say, Spain or something, you might be used to that being a decimal, where it differentiates, the tenths, hundredths, etc. Here, that is not the case. It differentiates just getting bigger in the whole numbers. If we want to get into the tenths, I would have something like a 0.5 after this. So after this, we would have decimals, and then we would have tenths afterwards. So let's say a 0.5. Then we would have hundredths for a 1, and then we would have thousandths after that. We're not going to go too far into tenths, hundredths, thousandths, etc. That's basically getting at fractions after those whole numbers, because again, those are not part of the whole numbers over here. But they're kind of good to keep in mind that that's differentiated with a point called the decimal, versus we use commas to differentiate those more positive whole numbers here. Or I shouldn't say more positive. Just, getting bigger. Because, if I magically turn this negative, in terms of sort of the general absolute value, place value would be the same as well. But the main thing that this is useful for is rounding. So in particular, you have to know what the different place values are in order to know how to round them. So if I have, let's say, this other number here, this initial 7 is in the millions, so that's 7 million. Then we have 100,000s, 10,000s, thousands, hundreds, tens, and ones. Now, in order to really kind of differentiate this, maybe even would be easier to sort of count from smallest to largest place value in order to know which one's which. And then again, anything that comes after a decimal point, that's getting into your fractions. So that's getting into your small decimals. That's really a future section that we'll get into that a little bit more, but those are often important when it comes to rounding as well. So I'm just going to encourage you to pause your video to do just a quick check for understanding to see how you're doing about place value here. All right, welcome back. So let's go ahead and talk about this. So if we're wanting to know the place value of the 6, well, we have the tens. We have the ones. Then we have the tens. Then we have the hundreds. Then we have the thousands, the 10,000s, and finally, we're at the 100,000. So really, that's indicating the value 600,000 here, because it's in the 100,000s place. That 6 represents 600,000. I would break down that number into 3 million plus 600,000 plus 80,000 plus 4,000 plus 200 plus no tens and then plus a 1. Which digit is the hundred thousands place of 2,174,538? Well, the hundred thousands place is going to be right here. This first block is your hundreds, the second block is your thousands, and your third block is your millions. And in this second block, the hundred thousands place is a 1 there. If we want to know the value of 9 in 79.348, well, it's actually in the ones place. It's just a 9. Versus the value of the 7 is 70. Which digit is in the tenths place? Well, tenths is indicating those decimals, not technically whole numbers, but good to kind of think about a little bit. Tenths place here would be that first number right after the decimal place, so it would be the 6. And it really actually represents 6/10, aka 0.6. Again, something we'll touch on much more in a future video. In the number 6,304, 6 has a greater value than the 4. That is true, because what is the value of the 6? It is 6,000. Versus the 4 literally just represents a 4. It's in the ones place there. Similarly, in this case, the 3 actually also has a greater value than the 4, because the 3 is representing 300. Circle all the digits in the thousands place. So the thousands place would include this 3. It would include this 6. Again, that's kind of the immediate number right before the comma, and it would include that 9. When it comes to rounding rules, that's really where you care about place value, is you have to know, hey, if it's asking me to round to the nearest 10, I look at the lower place value, in this case the ones, and then I determine if I round up or down. If the number that's just lower is 5 or greater, you're going to round up. So 5 or more, add more, that means that you're going to round up. If it is 4 or less, round down. So let's take a look at some of these examples. So in 54, for example, 4 is the number we'd pay attention to. That means round down to 50. Versus 55, 5 is the number we pay attention to. That means round up to 60. And really what you're determining here is if you're rounding to the nearest tens, you're essentially trying to determine on the number line which is he closer to. So the number 54 is physically closer to 50, so that's why we round down. Versus 55, he's technically halfway through, and we say halfway through we're going to round up. Something like 58, again, he's closer to 60, round up. So when you're checking yourself, you should be thinking conceptually, which number am I closer to that I'm sort of debating between. Similarly, for rounding to the nearest 100, if I had something like 415, well, what I'm really asking there is, am I closer to 400 or 500? Well, 415 is closer to 400. What lets me know about that? Well, that 1 is 4 or less, so I have to round down to 400. And here's some just more examples. You can kind of peruse at your own pace, but let's just take some time to practice. So what I'm going to encourage you to do is pause this video, practice with these numbers, and then check to see if you get the same thing. So here, for find the place value of the digit 2 here, that's in the tens place. So you'll want to keep that track because it goes ones and then goes tens. So it really has the value of 20 is what it's actually depicting there. If it says round 14,125 to the nearest 100, well, the hundreds place is right here at the 1. So the number we're actually going to pay attention to is the 2. And actually I just wanted to highlight the 2 there. So I'm going to underline it there. We're going to pay attention to the 2. The number 2 is less than 5, so that means round down. So it's going to round down to 14,100. The number 14,125 is closer to 14,100 than it is 14,200. Similarly, round 14,178 to the nearest hundred. Again, we're looking at the same potential number to round up or down. But the 7 this time, 14,178, is going to be closer to 14,200. 7 is above 5. So if we're sort of visualizing this, nearest hundred is either going to be 14,100, 14,200. 14,125 is closer to 14,100 versus 14,178 is closer to 14,200. So he rounds up, the other one rounded down. Or in short, I'm just going to kind of start doing the shortcut way. You're just paying attention to that number below. Is that number just below that place value 5 or more? Great, round up. 4 or less, round down. So to round this number to the nearest thousand, the thousands place is a 0 here. The number right next to it is a 6. 6 is greater than 5. So he's going to round up to 81,000. If I'm rounding 382 to the nearest 10, well, the 8 is in the tens place, so I'm going to pay attention to the 2. The 2 is less than 5, so he's going to round down to 380. If I'm rounding 104,501 to the nearest hundred, the hundreds place is the 5. The 0 is the place right next to it in the tens place. 0 is less than 5, so I'm going to round down to 104,500.